So at the end of the last video, we left off with this question. Is it possible for an infinite geometric series to exist? So can we take an infinite number of numbers, add them all together, and get a finite quantity? And this is something that for many students, it blows their minds because it can exist. We can take an infinite number of numbers, add them all together, and get a finite amount. It requires some calculus to prove this, so we're not going to go into the proof of why this exists. But the sum of an infinite series is defined whenever this inequality is true. So if our common ratio is between -1 and +1, but not equal to or larger than either of them, we find that the sum, notice we drop the n because n is now infinite, is equal to the first term divided by 1 minus the common ratio. It's an incredibly straightforward and profound formula, but it only exists if our common ratio is between -1 and +1. So let's do a couple examples. So on the left, notice that we want the infinite sum of the expression 5 to the power of 2/7. And now this should really have an n-1 up there. So forgive that little typo. So our first term is 5. R is 2/7. And so when we plug this into our formula, S is equal to our first term divided by 1 minus 2/7. We can rewrite this so that we have a common denominator inside our denominator. So 7/7 minus 2/7. 7/7 minus 2/7 is 5/7. And we can divide fractions by multiplying by the reciprocal. So we have 5/1 times 7/5. The 5's cancel, and what we're left with is 7. So if we add up an infinite number of terms, we only get 7. Never gets any bigger than 7, no matter how many more terms we add. The reason this happens is because every time we multiply by a fraction, the size of the next number in the sequence becomes smaller and smaller and smaller. And so eventually, the terms are so small that they don't really add anything. It's like we're practically adding 0 every time. Because the size of each new term, ends up becoming smaller and smaller until they're infinitely small and almost equal to 0. So let's mix up our color choice. How about a bold red? Notice that our terms are getting smaller. And so we need to figure out our common ratio. So 27 divided by 36. 27 divided by 36. Let's see. There's a common factor of 9. So if we divide the numerator by 9, we get 3. If we divide 36 by 9, we get 4. So it looks like we're multiplying by 3/4. Let's test another one. Let's do 48/64. What is 48/64? If you're feeling a little bit low on cognitive power, use your calculator. 48 divided by 64. I think there might be, or I typed it in wrong. 48, I typed 45 the first time. Divided by 64 is in fact 3/4. And of course, now that I've used my calculator, I can think through that, oh, never mind. The thought left me. For a second, I had it, and then it was gone. In either case, we have our first term. We have our common ratio of 3/4. We can use our formula. S is equal to 64 divided by 1 minus 3/4. So that's 64 divided by 4/4 minus 3/4. That's 64 divided by 1/4. We keep the numerator, we flip the denominator and change it to multiplication. So we get 64 times 4 over 1. And 64 times 4 is going to be 256. So notice that this infinite sum gives us a much larger number than the first one, because as opposed to starting with 5, we started with a much bigger number. And so the numbers took longer to reach 0 or to approach 0 to the point that they don't add anything more to this sum, and we just stay at 256. Let's do a couple more examples. Here we have the infinite sum. Again, there should be that n minus 1 in the numerator right there. So we have s is equal to our first term, 7 over 3, all divided by, this time I'm going to skip ahead a step and write 5 over 5, so I have a common denominator. And then let's see. We have 7 over 3. And then 5/5 minus 2/5 is going to be 3 over 5. So we have 7 over 3 times 5 over 3. And so we get 7 times 5 is 35, all divided by 9. And this is an exact answer. It's a fraction. We don't have to simplify it any further. It's just 35 divided by 9. That is our sum. Here, we can see that A1 is equal to 1,000. Notice that we multiply by 1/2, but it's negative because we change signs. Since we change signs again, we're once more multiplying by negative 1/2. So R in this case is going to be negative 1/2. So our sum is going to be S is equal to 1,000, all divided by 2 over 2 minus negative 1/2. So we have 1,000 all divided by 2/2 plus 1/2. So we have 1,000 divided by 3 over 2. So we have 1,000 times 2 over 3. And that gives us a grand total of 2,000 divided by 3. Once more, it's a fraction, but it's an exact fraction. So this would be our final answer, 2,000 divided by 3. All that's left in this lesson is the extra practice, as well as the graded homework. So these will be available for you on GoFormative. That wraps up this lesson, and I believe there is only one more lesson to this module.